Okay, we got one more for 6 here, right? Now we're supposing instead of this being 25 degrees, right? This angle right here is 30 degrees. Okay, and then we want to know what is the mass of B if this is 15 kilograms, right? What does this mass equal so that the thing doesn't accelerate, right? The plane is frictionless. I think what we do here is we figure out what this parallel force is, right? So that's going to be the force that's causing the acceleration, right? So the mg sine theta, right? Okay, well, this would be 15 times 9.81 times sine of 30. Well, sine of 30 is 1/2, right? So let's see, 15 times 9.81 times sine of 30. That's 73.575. Okay, that's why this is going to end up being half of that mass, right? Because this is half the weight of this thing, right? So what that means is that this guy here, if that's the force acting down the plane, right, then this force here, if this force is 73.575, right, if that's what that is, then there will be no acceleration, right? It could move up or down at a constant velocity, but it wouldn't accelerate because there's an equal and opposite force on either end of the rope. So basically this problem is simply what is the mass of B such that it weighs 73.575, right? So weight is mg, right? So 73.575 equals m times 9.81, right? And this is the mass of B, right? So if I divide that by 9.81, of course I'm going to get 0.5 times 15, right? I get 7.5. Okay. You could just look at this and say, well, gee, if it's a 30-degree angle, you've got half of the weight of that acting down the plane. So this would have half the mass to have half the weight. Anyway, yeah.